and of course, B. Problem 11 says to find f plus g, f minus g, f times g, and f divided by g. That's the algebra of functions. So quite literally, you're going to use the functions that they give us, and then there's just a bunch of algebra. Not even really a bunch, but I mean, there's enough to where you need to make sure that you can solve them. For my b, I have f of x equals 3x plus 8. And then for my g of x function, I have x minus 7. So for f plus g, I've got f plus g, and that's of x. So what I do is I take my f of x and I add to it my g of x. And if I do that, I have 3x plus 8. Here I just have plus x minus 7. Y'all, we combine like terms. In order to combine like terms, when you're dealing with variables, they have to have the exact same variable and the exact same exponent. Because the rule is that we keep and keep. You keep the variable, you keep the exponent. So they have to be the same, right? If they're not the same, how do you know which one to keep? Here I've got a positive 3x and a positive x. Looking at the coefficients, signs are the same, so you add and keep. And then for your variables, you keep and keep. And then those are actually like terms also. They're just plain numbers that don't have a variable attached to it. You just combine them. You just look at the signs. Here, you've got multiple different ways you can do it. Enter 8 minus 7 in your calculator, get 1. You can just look and see that 8 minus 7 is 1, or signs are different. You subtract, keep the sign of the larger. Pretty much everything y'all hear out of my mouth is the way I teach my elementary algebra and my intermediate algebra. So if there's something you don't understand, make sure you ask me, okay? Because I'm breaking it down as much as I can, okay? So this is going to be, it's going to look kind of ugly here, but f plus g of x. Okay, so that was me adding the two functions. It also told me to subtract the two functions. There's a very important thing that you have to do whenever you subtract the functions. I'm not just subtracting something in my g of x from f of x. I'm subtracting the whole g of x from f of x. So as far as notation is concerned, let me go ahead and write f minus g of x. What you do is you take your f of x and you subtract from it your g of x, right? Now, what is it? My f of x, I have my 3x plus 8, right? And then when you look at the operation, it's a negative sign. It's minus. And then you use parentheses here, y'all. If you don't use parentheses here, you're essentially only making one term in your g function negative. But when you do use parentheses, we're actually subtracting the whole thing. It's very important that you do that. And my g of x is x minus 7. So first and foremost, distribute that negative sign, which technically just makes your signs of the binomial inside of the parentheses change. It was positive, now it's negative. It was negative, now it's positive. Now, combine like terms. So my f minus g of x equals, I've got positive 3x minus 1x. Signs are different, so I subtract. I keep the sign of the larger. Because I'm combining variables, I keep and keep. That's just 3x minus 1x is 2x, okay? And then here, positive 8, positive 7. Signs are the same, so I add and keep, 15. And that would be the answer for me subtracting the two functions. Okay, now we multiply the two functions together. And I don't want to say of course, but of course, because we're doing multiplication, both functions need to be in parentheses because those parentheses is what tells us to multiply. That's what implies multiplication. So I put my, I was just going to go ahead and do it. What's happening, y'all, is this. F of x times g of x. Okay, so I'm going to put my f of x in parentheses. I'm going to put my g of x in parentheses. Because there are two binomials, bi meaning two, binomial meaning this has two terms, this has two terms, right? I'm going to scoot up, y'all. What I do is FOIL, first, outer, inner, last. Okay, I take my two first terms of the binomials. That's this right here. That's the first term in this factor. This is the first term in this factor. When you do that multiplication, you get the 3 times the 1, right? 3 times 1 is 3. Signs are the same. Those are both positive, so this is positive. Now, when you do your variables, there's exponent rules that state when you multiply variables, if they're the same variable, you keep the variable and you add the exponents. So x times x is x squared, right? Now, using FOIL, the second letter is O, which is outer. You take these two terms that are on the outside. There's 4 numbers there, right? These are the ones on the outside. So I'm going to multiply these two together. If you do 3 times 7, you get 21. Signs are different, so it's negative. Don't forget your variable. My multiplication that I just did was 3x and the 7, right? So because that x was involved in the original multiplication, it's going to be a part of my product. It doesn't just fall off, oh, this doesn't have an x, it goes away. No, you keep that x. Don't forget it. Now, third letter in FOIL is I, which means inner. Of these 4 terms, those are the inside ones, right? So now I multiplied these two. When you do 8 times x, you just get 8x. They're both positive, which means my product is positive. Lastly, in FOIL, you do the last terms. First, outer, inner, last. So looking at this pair, that's last. Looking at this pair, that's last. Let's multiply them together. 8 times 7 is 56. Signs are different, so it's a negative 56. And now I've gotten to the point to where I can combine like terms. Okay, so my 3x squared, there is not another term that has that same variable, same exponent. So nothing can be like combined with it. So I'm done with that. If you look at your middle terms, those both have an x to the first power. They're alike. They can be combined. Like you can do math on them. So what I do is I look at the numbers. 21 and 8, those signs are different. So I subtract, keep the sign of the larger, keep my variable, keep my exponent. Use those. What I have left is a negative 56. So that is the product whenever I multiply those two functions together. Whoop, almost crossed out my answer. That is the correct answer. Okay, so I just went ahead and did the algebra functions for the addition, subtraction, and multiplication. It asks you what the, It asks you what the domains are. And your domain for these functions, if you look at my f plus g, I got a polynomial. If you look at my f minus g, I got a polynomial. If you look at my f times g, I got a polynomial. The domain for all 3 of those are just all real numbers, negative infinity, positive infinity, okay? Kind of did that as a second thought because I just know they're all the same. They're polynomials. Now, when I do the quotient rule, basically when I divide them, it won't be. I'm actually gonna have to figure out what that domain is based off of what my denominator is. So if you take f of x and you divide it by g of x. So if we do f of g of x, what we're doing is doing f of x over g of x. My f of x was 3x plus 8, is that right? And then my g of x was x minus 7. Mathematically, y'all, there is no way to factor this any further. There's not a trinomial on the bottom. It's not, you know, I don't see common terms to cancel. It's just my g is under my f, and I can't do anything else. So the only thing I'm concerned with now is what is my domain? What causes that to be 0? Because that's somewhere I know that like it would be undefined, and we can't have that. So it can't be that. And if you notice, if I add 7, right, the positive number 7, I'll get 7 minus 7, which is 0. That's the only number that I could put in the denominator that causes this function to be undefined. So 7 is what it cannot equal. My x cannot equal 7. So for my domain, it can be all numbers except for 7. Does that make sense, y'all? So far, so good? Yeah? Okay. It gets hot up here. Okay. I'm actually going to switch to a new piece of paper to start 12, just because I know it's probably going to take a whole piece of paper. So for 12, I chose to do B because apparently I love B. And also, if you look at your review, there's a number missing. It was a typo on my fault. On like, it was on me.